Hi everyone, welcome to this video on differential equations involving a function of the independent variable. Now, as we've talked about, differential equations are equations that involve a dy dx or a d squared y dx squared. So, and also the solution to them is when we have an equation of the form y equals something and it no longer has any derivatives in it. So when we say find the general solution to a problem, what that means is we need to make it so it says y equals, and because it's a general solution, it's okay for it to have a variable in it still. So the other thing here is that we basically have that if dy dx is equal to f of x, then y is equal to the antiderivative of f of x with respect to x. And this is all I was talking about when we say the independent variable, because the independent variable is the x variable. So just remember as well that the independent variable always goes on that horizontal axis. So when we go through these questions here, find the general solution to these. So all I'm going to do is say that y is the antiderivative of 3x to the 5 plus 2x cubed minus 7 with respect to x. And so that becomes 3x to the 6 over 6 plus 2x to the 4 over 4, and then minus 7x with a plus c on the end. Can't forget to write that. And just simplifying that down, we get half x to the 6 plus half x to the 4 minus 7x plus c. So this is a general solution because we've got the plus c in the equation. And we could vary that value of c to get lots and lots of different solutions. If I go on to the next one, so in this equation we've got dy dt, that's alright, so it's just a slightly different variable there. So y is equal to the antiderivative of 1 over 1 plus 4t squared dt. Well, you might recognise that that's going to be an inverse tan, and so to do that I need to make so the coefficient of the t squared is just 1. So I'm going to take that 4 out the front, and then I'm left with 1/4. Not sure what happened just there. Anyway, 1/4 plus t squared dt, and well, the other thing is that I need the numerator to be half. So and that's because it's the square root of this quarter here. So integral, make that a half, and then I've still got a 4 with the 1/4 plus t squared dt. Of course I can't just turn 1 into a half without doing anything else, so I'm going to also have to double it out the front to counteract that. So I'm now going to move the 4 from the denominator right out the front to give 2/4, which is just half. Integral of half over 1/4 plus t squared dt. And now we should be good to solve this. So we end up with half inverse tan of t over half, which is just going to be 2t. And then we always have to have the plus c on the end. The third problem has a d squared y dx squared equaling sine 4x. So in this case, we're going to have to anti-differentiate twice. So first thing I'll do is get dy dx, which is just the antiderivative of sine 4x with respect to x. When we anti-differentiate, this becomes negative 1/4 cos of 4x plus c. So then from there I can get y by anti-differentiating again. And so that's going to give negative 1/16 sine of 4x plus cx, and then I also need to have plus d because I anti-differentiate again, so I'm going to have to introduce another variable there. So these are the three general solutions to these problems here. Again, noticing that they always have those C and D variables there. You might just scroll down a little bit. So find the family of curves with gradient dy dx equals e to the half x, and hence find the particular equation of the curve so it passes through 2 and e. When we talk about a family of curves, this is just basically saying that when we anti-differentiate something, we get y equals an equation plus c, that we can vary that value of plus c to make lots and lots of different curves that all have the same gradient, but will all have different y-intercepts and those sorts of features. So all I'm going to do is anti-differentiate. So y equals the antiderivative of e to the half x dx, which just becomes 2e to the half x, and then plus c. And if I use the coordinates that I have there, then I'm going to get e equals 2e to the half times 2 plus c. So that means e equals 2e plus c. So therefore c must equal negative e. And so therefore y equals 2e to the half x minus e. And well, there we have it. I will make another short video in just a moment just to go over how we can do these kinds of problems using the calculator. So I'll see you then.